Hello, I'm Lori, and welcome to another one of these software short videos. Today's video is on what is a unit test and how to use Gcov for both doing unit testing and doing MCDC. I wanted to do these two separately, but it turns out they're totally interrelated. MCDC is used for unit testing, so I combined them so it has a long title, Kill Two Birds with One Stone. In this video, what I'm going to go over is all the questions about a unit. What is a unit? Why do you unit test? When do you unit test? And how do you unit test? And for the how, I'm going to go to a hands-on example using Gcov to unit test using MCDC criterion. So if you haven't seen, if you don't know what MCDC is, I have a companion video on MCDC testing that you can look at. I'm going to do this with a couple of PowerPoint charts first and then break into the demo. So what is unit testing? First, we got to start with what is a unit? So this whole thing that I've shown is a unit. It's a function or a method. And some things to kind of point out. The thing I have in red is a decision, and the individual elements of that decision are conditions. They all evaluate to true or false. I'm going to be kind of going through the paths through that when I talk about unit testing, so it's good to know the terminology. So why unit test? Well, really, if you write a snippet of code, it's supposed to do a certain thing, you need to test that it works right. And I look at unit testing as really two-pronged. One is it behaves right, and two, all the paths through it are tested. So why should units be tested? Or sorry, when should they be tested? Early in the development life cycle, they call this unit testing phase. And this is also when MCDC is done. It's associated with what you do during unit test. How are units tested? So basically, you usually use a test framework that calls this function, I'm calling it checkabort, multiple times. So in this case, you'd call it 4 times. This would actually do a full MCDC testing of that unit. Each time, testing to make sure the expected result is what you wanted, and this test salted paths. I'm going to go through this in example. So there's several ways, besides making sure the unit is doing the right thing, there's several ways of testing the coverage, which is the second part. There's line coverage. In line coverage, you would make sure that all of these lines have been tested, lines 1 through 11. In branch coverage, that implies that all the branches have been tested, which would be everything after the then, and everything after the else. So lines 7 and 9 in this case. Now, path coverage is where you get into the decisions and the conditions and the logical paths through the code based on the true and falseness of these values. And that's where MCDC comes in, where it exercises the minimum set of meaningful logical paths through that. And another point on how to run unit tests, usually you use a unit test framework. I was going to name some here, but I Googled it. You know, you can look up on Wikipedia and Google on the popular ones. There's tons of unit test frameworks, some free, some not free, but you need to pick the one for your language. It's usually broken out by language. One thing I did want to point out, though, is UT Assert is one unit test framework that works well with Core Flight Systems, CFS apps, which is a NASA flight software framework. Now let's switch gears and go into using the Gcov tool to do this unit testing and to do MCDC coverage with it. Gcov is an open source tool that is used in conjunction with the GCC compiler to help provide code coverage statistics when you're unit testing, that second part of unit testing. It gives you statistics for line, branch, and path coverage. And in order to understand how it relates to MCDC, we have to go into how it works a little bit. So what I've popped up here is what they call a binary decision diagram. If you take that decision on the previous chart, I've renamed it A, B, and C, and you want to represent it as a decision diagram, this is what it would look like. If you consider A, if A is 1, the decision returns true. If it's 0, then you go on to evaluate B. If B is 0, the decision returns false. If B is 1, and then you have to look at C. If C is also 1, then the whole decision returns true, or else it returns false. And this is a tree-like BDD. Now the question is, can Gcov be used to meet the MCDC criteria? And the answer is yes, but some extra work has to be done to make sure all the decisions in your program look like the one on the left versus the one on the right. And I'll go into this a little bit, but if you do make all of your decisions in your code tree-like, then this representation has been proven to be equivalent to MCDC. And there's several good news about this. The good news is you can convert all non-tree-like to tree-like. In this example, you just reverse the order. I just had the order reversed. And there's actually an open source tool available to identify places in your code you have non-tree-like. And all of this, all non-tree-like can be converted to tree-like. And it has been shown additionally that in very large code bases, the amount of decisions that are actually like this naturally are very few, like in one study, less than 1%. So all this is good news for using Gcov to do MCDC. So let's go into why. Why is that? What is the nuance between these two forms of trees? Let's just say up front that there's a statistic in Gcov called taken at least once, and that's the one that you look at when you're doing MCDC. If you get the taken at least once to 100% and all your decisions are tree-like, you can be confident you have done MCDC. So looking at this example, the tree-like diagram here has 6 edges and 4 leaves. And Gcov is going to look that these 4 leaves have been tested. But if you have a graph in your code, you're going to end up with less than 4 leaves. In this case, you have 3 leaves, and it's a graph rather than a binary tree. So Gcov will look and call it 100% if you actually test only these 3. So that's where if you have a non-tree-like decision, Gcov is going to tell you have 100%, basically incorrectly reflecting MCDC coverage. But if you have it in the tree-like, it'll correctly say that you have whatever, 83% of the tests. So the overall guidelines for using Gcov for MCDC, and I have the invocation here, run GCC without optimization and with these arguments, and then run Gcov with the -B switch, and then you get this statistic called taken at least once. And if you drive that to 100% and you periodically make sure all the decisions in your code are tree-like, then you can be confident that you have achieved MCDC. So I'm going to show a whole demo with this, but before I do, I wanted to just flash up the references. I want to thank our friends at ESA, European Space Agency, and the Coverture Project, who really did all the work on this because they wanted an open source tool for MCDC, and there's great reading there. And I'll go to the demo. Now for the demo part. So hopefully the font is readable. I have 3 windows up here, and here's a list of the files. So in my upper right window, what I have is the unit under test, the thing we were talking about, A or B and C, and that is called checkabort.c. There's a corresponding .h file, and below it is a main program, which would really be like a main in a unit test framework. That's called Gcov test.c. And then what that does is, in this case, it calls this checkabort with some values for the A, B, and C. And then it calls a function here that I wrote called check result. I'm doing this again, brute force. Unit test frameworks generally help you do this, but it can all fit on one screen this way. So the first thing I wanted to emphasize is I mentioned unit testing is really two phases. The first one is you have to make sure the results returned by what you're checking are correct. And the second thing is coverage analysis. So I want to show you the test for the correct result. So in this first run, I'm going to show you that I'm going to check result and put in an expected result of false, which is incorrect, because if you call this with A as a 1, A is 1, and it should return true. So I'm just going to run this and compile and run it and see that it did print out this thing that says unit test failed, because it was not as expected. Now, again, I just wanted to show that to make sure we don't forget that, one of the main things of unit testing is to make sure that the results returned are correct. So now from here on out, we're going to talk coverage. So, and let's go over the call that I used for GCC. As I mentioned on the previous page, you run GCC with optimization off and these flags. Then what happens is after GCC runs, it generates these files with the GCNO, and you don't read these, you don't look at them. They're data that's needed by Gcov to analyze the trees. Then if we run Gcov over what happened before, you notice I only had one test. With the -B option, you get the statistics, lines, branches, and taken at least once. And you notice that none of these are 100%. If you look in the, there's a file that's generated after you run Gcov, and it's got a .gcov at the end. And if you look at this file, it will give you sort of details on what was missing. So looking at this check abort function, you can see our AND, A, or B, and C, and then you see a bunch of stuff here. Well, these 6 branches listed correspond to those 6 edges. And then you can see that a lot of them are not executed. There's a taken 0 here, which that is the thing you can search for in all of your Gcov output. If there is any taken 0, that means there is at least one path that has not, logical path that has not been executed. So let's go here and add some more tests. I'm going to go to this one here and add 2 more tests. So add 2 more tests, run GCC, run Gcov, and what do we end up with now? Well, now you have 100% lines, 100% branches, but you still have this taken at least once at 83%. And you can look here, there's still this taken 0, which that's the thing. If there's taken 0, you haven't done all the MCDC. But let's just switch gears just a tiny bit and remember what I was saying about tree-like versus non-tree-like. So with these 3 tests, you don't have all the coverage with tree-like. But if I go in here in this file here and turn on the non-tree-like branch and recompile and rerun Gcov, you'll see I get all hundreds. And if you look at the Gcov output file, you'll see that these takens are all above 0, which is a false sense of security that you actually tested all the Gcov, because this is a non-tree-like branch. So if you do correct it, like we had it before, and I already showed this, but I can show it again. then it goes back to 83. So you need another test to do the full coverage. So now if I come back in here and I add the last test, recompile, and run Gcov, now I'm at to 100%. So now I can safely say that this function checkerboard has been tested for all the correct values, true, false, and it has been 100% Gcov unit tested for MCDC criteria. One addendum, I have these other tests written down here. That would complete the full set of 8 tests needed to do full MCC, multiple condition combination coverage, which is all the permutations. But the note here is you don't need these tests. They're redundant. Doing these 4 tests, MCDC actually tests all the meaningful combinations to logically test this code. That takes care of this software short on what is unit testing and how to use Gcov to help in unit testing and doing MCDC. I hope you found it informative. Please provide me any comments or any suggestions for more of these, and have a good day.